Industrial design, we've done some more of it. Well, we've been doing it for a while. How long have we been doing plastic?
I don't know, what even is it? Because like, you know, I think we just made it up as we went along, to be honest. Well, you tell us what industrial design is.
It's been 10 years pretty much since the first case design that we did. So that was a range of concepts for the very first case that went into manufacture, and then that really kind of set the scene for all of the peripheral products we've done in terms of industrial design. So industrial design being, I guess, how the peripheral products and accessories we do look, but also how they function for the user. So yeah, it's been great to be involved, and we've got a good family of products now that have come out, and some new ones to talk to you.
But you weren't with us at first, right? You were somewhere else.
Yeah, so I worked for Kinnear Dufour. So they're a partner of ours now. So I was an industrial designer there for 9 years, and I remember the moment the first brief kind of landed on my desk to design the Raspberry Pi case, and yeah, it grew on me the importance of that, and kind of really got stuck in. And yeah, I think we produced quite a lot of designs in that first presentation. I think it was a good sketchbook of stuff. Yeah.
It generated the infamous hacksawing moment.
Yeah.
We brought prototypes in and we got the hacksaw out and started sawing. Wouldn't it look better if we sawed the corner off it like that?
Wouldn't, yeah.
We didn't select that.
Really happy we got a photo of that.
Yeah.
That's kind of it's client feedback, and then there's taking a hacksaw to a prototype.
Yeah.
But I remember coming to see you guys in Bristol.
Yeah.
I think I gave a talk in Bristol, and then I dropped by the office and saw all the work KD had been doing. And then it was about a year, wasn't it? So we were about a year in.
Yeah.
Must have been 2013.
Yeah.
And the market was dominated by, well, there's Pybo, obviously.
Yes.
And then
there were some cheapy cases.
There were some cheapy cases,
like,
and so there was kind of like the beautiful. I mean, I remember there was like the beautiful, but deluxe, sort of deluxe priced case, and then there were a lot of sort of discount 50p cases that look like 50p cases. Yeah. And I remember that sort of brief is like, can we bring like a good design ethos to a relatively low price point?
Yeah, and hit that middle ground between the two. Yeah, there's definitely in the market groups at either end, and there's good opportunity kind of right in the middle of well-designed case that is at an accessible price point.
Yeah, and then you drew the Boba Fett corners and then never delivered them to me. So
no, sorry about that.
So disappointed.
Yeah, the Raspberry Pi, well, what was then the Raspberry Pi B Plus case, because that was before we launched B. It was at the same time we were developing B Plus.
Yep.
To the new form factor. We knew we had a new board form factor coming, and we wanted to rendezvous with that with a good case design.
Yep.
And yeah, it had a clip-on lid, didn't it, and clip-on sides, and originally had a clip-on end, so you had that kind of the Boba Fett, what he calls the Boba Fett thing, the kind of helmet.
Yeah, it was the helmet corner, wasn't it?
Yeah. And then the end piece went away.
Yeah, so you ended up just with like, half a Boba Fett. Yeah, no, that's it, yeah.
Stretched Boba Fett. But yeah, so that came out. That must have come out at the start of 2015, because I think that came out round about Big Birthday Bash 3. Yeah. Do you remember standing in the office clipping them together?
Yeah,
we gave one to everyone who came to the Big Birthday Bash.
Yes, the most expensive manufacturing line in the world. There's like 12 senior software engineers all sat clipping pieces of plastic together. Yeah, that's it. Yeah. 1,000? Was it 1,000? I think it was.
It was a lot. It was certainly many.
It was for the birthday bash. Of course it was. Yes, that's
right.
Yeah, I remember.
It was kind of fun, right? And then we've been working with the same plastics, the same molding partner all the way through as well.
That's right. Yeah. So that's been great. So we've kind of built a knowledge of kind of what to do with plastics, and that produces a really good kind of cosmetics and functionality. So yeah, we have our own stock of plastics, and our own partners that we use to develop through.
Yeah, and that's T0 in Dudley. So we should probably talk about. So we did a case. We did a case for Raspberry Pi 3. Then we did a case for Raspberry Pi 4. Probably somewhere in the middle there, we got mouse and keyboard. I guess we had mouse, and so we did case for Pi 3, mouse and keyboard. Of course, the keyboard design already being intended to become the Pi 400 design. Then the Pi 4 case?
Yep. Yeah, there's and 0 case.
They did 0
and
case.
3A case.
Yeah, and I guess 0 and 3A plus case, they sort of refined the design aesthetic a little bit. I mean, those I think start to feel much more like modern, much simpler. They lose the clip-on sides.
I think it was the simplicity that kind of simplicity encourage the direction of how we do things, because especially like A plus, or actually no, 0 as well, the idea is just a two-piece clip and clip together, and it's like actually
that a red base and a white lid can look as good as a red base with white sides and a white lid, you know, or better because it's cleaner. Yeah. So we had those, and then Pi 4 was the big. I guess Pi 4 was the big one, right?
Yeah. So that was the two-part case for the Raspberry Pi 4. So that was that was good. I think aesthetically it was better, and yeah, I think it's done quite well.
Does that have the polished? That has the polished edge piece on.
Yeah. So that's the first time I think we brought that in, just to add a bit of detail around the lid. So it's got a gloss detail all the way around the chamfer, which kind of adds to the look of it.
Because we have the rest of the case, the whole Pi 3 case is textured, right? It has a fairly fine matte texture on it.
Yeah, and I think it was successful where we have logos and we have the selective texturing, so matte versus gloss textures. It's got, just adds that bit of kind of signature detail that's really nice, and the more places it can exist on the case, the better. I think it's quite a nice detail to have.
Yeah. And then you have two parts, and then you have a light pipe component that brings the colour of the board LEDs out through the wall. Yeah,
that's it. Yeah, and some silicon feet to make it stable on a desktop surface. So yeah, it was pretty simple case that.
And it was a nice product, but some people felt there was a problem with it, right?
Yeah, Pi 4 got a bit warm inside. Got a little bit warm inside. So yeah, and that was when, what I did was spend quite a long time trying to work out how you could put a fan inside, like hold a fan inside in such a way as to drive some air through the case.
You bought a lot of Chinese takeaways.
Bought a lot of Chinese, cut up a lot of stuff and made lots and it was that interesting thing where I started out by making quite complex things that sat into the case, and then what I ended up with was like a piece of, a single piece of card. That was and just like a little hot, and then it sat there and it worked.
Diagonal fan.
Yeah, and that's and that just works, and you're like, okay, yes, I can get it. So I can get it to that simple, and that's like a really great thing to do. It's like a bit, as we've done with this one. It's like that kind of like actually realizing that it doesn't need to be complex to get there. But yeah, that kind of reducing the temperature inside the case is just like when you're trying to do something really hard with a Raspberry Pi, you can consume a lot of energy, and you do need to get rid of it.
Yeah, so this generated the fan shim design, which is clips inside the lid. Yeah. It latches onto the inside of the latches.
Yeah. Almost like they were designed for it.
Almost like they were designed for it. Absolutely, 110% was not designed for it. And that's sucking air in, but that brings air in over the top of the jack space, particularly the Ethernet jack. Yeah. Pushes it down onto the board, and then kind of exhausts it through the SD card slot and other ad hoc spaces.
Yeah, and that was quite interesting because you can do things like take the infrared camera. You can put the thing on the table, and you can take the infrared camera and point it around it. And you can see where the table warms up to say, well, where's the heat going? And that's actually quite nice. The infrared camera is brilliant for that kind of stuff. So yeah, really useful.
So the interesting thing I think for me about the thermal behaviour of Raspberry Pi 5 is that it is a lot cooler at a given workload compared to, because it's on the processors. There are various architectural efficiencies in the system, and in particular the processors on a more advanced process node, and is a more efficient core. Instruction for instruction, even on the same process node. But because it's such a powerful core, it has this kind of headroom.
Just goes that much further.
You can push it. Once you push it, and it's running 3 times faster, 2.5, 3 times faster than a Raspberry Pi 4. It can consume a little more power. So I think we can get, our worst case power consumption on a Pi 4 is 8 to 9 watts, and this is more like 11 to 12 watts with a pathological workload. At which point it's doing kind of 3 times the work. It's consuming 50% more power and doing 3 times the work, right? So
there's going to be a problem.
Yeah,
So we have to start, and that was our discussion. It's by design we might as well put this in there by design. Because there isn't, and again, since that point, it's kind of no, the case will be supplied with the fan, because if you don't, Like it's going to overheat, so it's like, what's the point? Oh, they're saying that again in the same situation. Like as you say, like it's not going to, like if you're just in idle, it doesn't overheat, so it'll be fine. Yeah. But it's just when you hit those
intensive use cases. Raspberry Pi 4. I use a Raspberry Pi 4 at home without a fan in the case, and it's fine because I'm using it as a desktop computer. I'm not just spam building the kernel all the time. So the idea was we needed to have something that had some sort of thermal solution in it. What was the evolutionary process that generated?
Sure. Yeah. So it really kind of was similar to kind of your process in creating the fan inside the Pi 4 case. It was an iterative prototyping process, really. So, what fan do we need? Where's the best place for it to be positioned? What's the spec of the fan that will produce good cooling performance and low noise? So that was the starting point. And
the biggest advantage he had, of course, is that he had a 3D printer. I only had the takeaway cards. Right, so I think
Yeah, you got delicious takeaway where he just got 3D printed.
Yeah. I remember Gordon handing me the box of knowledge. It's like takeaway bit.
All the things you're like, what is this?
To blow the dust off of it. But there's a lot of inspiration in there. It's good. But we did
some residual special fried rice as well.
It's great. I still got it somewhere. But I think we did some thermal simulation work, so we used a computer to understand airflow and replicate what a fan does in software. We did the thermal imaging things, but the best thing was just creating probably hundreds of prototypes, 3D printed, cardboard, and just testing different positions of fans, and then stress testing the Raspberry Pi, and then measuring the temperature. And we arrived at the 30mm fan directly above CPU, fix that, and then design the rest of the case around that effectively.
Right. So, and what you've ended up with, well, from this distance, that looks exactly like a RaspberryPi 4 case. So how is it different? What's the concept? What's the kind of airflow concept in the design?
Yeah, absolutely. So it's taken all the positive points from Pi 4 and then integrated the fan inside. But two main aims: create a cooling solution for the case, keep the Raspberry Pi nice and cool, but also improve its functionality, I guess, for people using it. What we've realized with our cases is people use it in many, many different ways. There's the out-of-the-box kind of desktop computer mode, but people hack, mount, stack our cases, and we've also built in some features that enable it to be a more useful case for more people in different scenarios. But I think the process is really fixing the fan in the right place, then understanding how it opens. All of our cases we like to clip together, so we don't necessarily like to hide the Pi away or make it hard to get to. We want to kind of allow people to interact with the Raspberry Pi inside. So making it all kind of come apart is really useful, so that's a base requirement. And then building in features that just make it more useful. So we've got mounting points on the base, so you can mount the case, stack the case, fix the Raspberry Pi in there securely with screws if you'd like. But I think a key thing with the fan integration is when you have a fan case, often the fan dominates the industrial design. So it's, the cases have got a big hole or lots of venting, and it's very much a fan case. Whereas we still wanted to keep the minimal nature of this, keep it quite simple, quite friendly looking. And that's the reason why the fan is actually almost hidden inside. So if I can kind of talk through features.
Take that one apart.
Yeah, so this is its desktop mode, fully assembled, and this is how people might use it as a desktop computer on a desk. But if you open the lid, so that easily plugs on, clips on and off, and you have the fan integrated right into the center of the case there. And this is purely based on thermal design. This is the kind of the best place to have the fan. It's the best kind of size of fan for cooling performance and noise. It sits directly above the CPU. What we kind of like with this is it's almost a two-mode case. You have this as a kind of discrete, minimal desktop computer, but you can take it off and almost have a project mode. So you've got breakout for GPIO. You've got extra mounting points revealed as well, places for cables to exit. So with these mounting points on top, it enables the cases to be stackable, so you can build something like this, a tower of cases. If that
those little spacers you've got there.
Spacers, yeah. So by a combination of screws, spacers, standoffs, GPIO header extenders, you can create different configurations, basically build the case into whatever project you like using those features. I think stackability was something we heard as being quite desired, and it's great to build in those features to make the case more usable. The other kind of good part about having these mounting features here is integration of hats. So often with a hat, you're almost occupying the space where a fan would be good to go. So what we've done is allowed hats to be mounted on top of the fan. So that produces something like this. It's just a mock-up there. So again, using spacers, GPIO, header extenders, you can have cooling inside, but all manner of hat mounting on top as well. The other feature of that is the fan is on a removable component. So this clear component can be taken out. So you don't necessarily have to use the fan if you don't want to. So for your example, with the Pi 4, using that at home as desktop computer, you might not need a fan in that place. You could take that out entirely. What's quite nice about that is we've got this kind of nice kind of picture frame style feature, and you can have the hats inside the case as well. And some of the more visual hats with banks of LEDs, really nice to kind of frame in that aperture and have a visual impact of the hat.
So if I clip the lid on,
yeah,
where's the air going in?
So we have about 1.5 millimeter gap all the way through.
Yeah.
So
I honestly, like, we spent a great deal of time, and I was kind of like, it's not going to work.
Yeah.
Like when I did it, I'm surprised that, and when you showed it, like, yeah, it works. I'm like, how did it not work for me then? When I was like, with all these little, I thought you just wouldn't be able to get the airflow through. But I guess because it's all the way round, then that's what really helps in that situation.
Absolutely. So although it's quite a small gap and it's discrete, we didn't want the fan to kind of dominate the design. The surface area of that gap, it equals the through-hole surface area of the fan. So that's a kind of direct comparison. So yeah, there was a lot of raising and lowering the fan to get it, the lids to get it correct. But yeah, it's a nice feature line. Again, like we've got vents on the base, but
and that's a change from the Pi 4 case with the fan shim is really relying on effectively air leakage under the PCB, primarily through the SD card slot, we think, to get air out. This actually has features for that.
Yeah, it's dedicated features. So deliberate air inlet through the gap, and then deliberate air exhausts through base vents. And we found with the thermal imaging that a lot comes out of the end connectors here. So we know where the air exits and enters the case. And the thermal simulation work we did helped us understand the path of the air through the case, so that was really useful. But yeah, it's an iterative prototyping approach to get the gap right, to get the position of the fan right, and make sure there was enough venting as well.
Who did the simulation? Was it Cambridge Consultants?
It was, yeah.
We have some help from the
consultancy.
They
did the simulation for the bulkhead design for the that thing. But actually, you did the one for this one, so
I hadn't had much experience in that, but kind of learned how to do it. So it's as part of a bolt-on to the CAD software, you could set up certain parameters with the 3D model in CAD, and it gave you a visual kind of interpretation of what the hot air and cold air was doing, which was quite useful. So the position and size of the vents were driven by that simulation.
And you've also stretched the case a little bit in width, whichever dimension you want that to be. It's stretched away near the SD card, which I guess helps with airflow.
Exactly, yeah.
And also makes it, there's a bit of a wrinkle, isn't there, with the previous case?
Yeah, well, the one problem is that I've always, people have wanted to have, can you have like a push-push connector like we have on the Pi 400, but I have no fingernails, so it's always annoying when we have that, and it's I've always said can we make sure that it's easy to insert and reset, which requires actually quite a large gap, doesn't it? And then it's quite difficult then to make it large enough and still look nice. I mean, that spent a long time with that.
We did, yeah. I think the size of that finger recess has been kind of highly developed, on different people's fingers and things. But yeah, I think that's quite a generous kind of feature for people, but it makes it a lot easier to.
And there was also the problem, I think, with the Pi 4 case. Sometimes you could, because of the way the board sat in the case, sometimes you could put the SD card and actually go under the board, and then you'd have to shake it back out again and find the slot. Whereas you don't have that issue with this one.
Yeah.
And I guess this is kind of an extension to the case space of that ethos that we have in the board designs, where because we always try and be incremental from generation to generation, we can fix problems. We're not just, if we did a completely different board design every generation or a completely different case design every generation, we'd make a completely new set of mistakes every generation. Whereas this time we can iterate and have some confidence each case is going to be better than the previous one.
So yeah, I think we've learned a lot from the ones we've done before, and this is the kind of culmination of that knowledge, I think.
But yeah, that point at there were two things so we have this extra bit over here right now that fixes two things. One is which means that the board won't lift up as you push the SD card in, won't lift in. But also we definitely saw some people taking Raspberry Pis and just pushing it and then forgetting their SD cards there and actually pushing it in, and actually then damaging an SD card. So that also stops that. If you try and do it, it's obvious it won't fit. And there's like we were discussing kind of like how the user interacts with the case is really important. How does it, because like again with Pi 4 there was almost this magic direct way you had to insert it.
Yeah, there was a sort of
there was like
that
connectors in first and then and that kind of thing, and then with this one we tried to get rid of as much as that so it would just go in any direction, but it would then have all those things, right? And you spent a long time on all of those, right?
Yeah, it's always a good design challenge because we have connectors around different sides of the board. So loading it in that end, which is the most intuitive way of doing it, is challenging to get distances to connectors. But I think we've arrived at a good point where the Pi almost just drops into place. It is intuitive, it's obvious. You don't have to learn a particular method for loading it in.
Yeah, but you can still take it out with the SD card and you can still put it in, but you just can't do that. It's obvious that it won't work. So
That's it.
And then the light pipe is a little bit more sophisticated because we grew a much desired feature on the board, didn't we?
Yeah, it's an on-off button. So yeah, it's you can click it, hold it down to power on the Raspberry Pi, and then hold it down to power down. And it also acts as a light pipe, so you get the status LED lighting up that button, so you'll have that external appearance of what the LED is doing.
There was a whole new tool for that one wasn't there?
Yeah, that was a challenge. I mean, it's fairly similar to the Pi 4 light pipe, but we obviously wanted it to move, and the other one we didn't want to move, so it has a kind of pivoting action, so you can press the button and activate the switch on the Pi 5.
But you also had some more software for that one.
Yeah,
to do the light pipe.
Yeah, it did. Yeah. So that was ray tracing software. So same kind of 3D software. We could light up the LED and then shoot the rays through, and then just understand whether we were directing the light in the right way through.
Because light pipe designers felt like a bit of a dark art, right? A bit hit and miss in the past.
Yeah, and you just there's that thing about kind of like making sure it wasn't just you didn't end up with like some dots that you couldn't actually see at any kind of angle, and you could only see if you look in the end. That trying to get rid of that, and so like trying to make it bounce around a bit was a good idea.
That's right. Yeah.
The
more lines, the better.
Yeah.
Ray tracing.
Yeah. But hopefully we've learned a lot that we can then use in the future as well.
Absolutely.
Yeah.
But it's been a good development, and I think it's been a nice evolution of the design language. It's just an incremental evolution of the design language. So I imagine, future products, will some of the stuff we've learned here is really going to help us with future products. Yeah. That's case. We should talk about, and that's one of, but that's only one of two cooling solutions for the product. Should we talk about the other one?
Yeah. So this is the Pi 5 active cooler product. So this is essentially an active heatsink. So it's a product that mounts directly to the Pi 5, which is purely focused on cooling. So it's made up of aluminium base plate heatsink, and mounted directly to that is a blower fan. So this fan blows air out sideways through these heatsink fins and does a really first-class job of cooling the Raspberry Pi 5. So it's been a great one to work on. We wanted it, the initial aims were to make it small and compact. Really, we knew it's going to live on the Pi 5 for quite a long amount of time, so the more it can kind of blend in and occupy the space we have and almost become a part of the Pi 5, the better. We occupy all of this kind of space in between the pretty feature-packed Pi 5, so the shape almost designed itself, but although it's a functional product, we wanted it to look good as well. So I think we've got to a good result. The way it mounts is by 2 push pins. So the Pi 5 has 2 dedicated holes for heatsink mounting.
It's kind of remarkable that along with everything else, James also managed to eke out another 2 mounting holes worth of space on the board. There's really not a lot of space.
That's great.
Yeah, and especially in this corner, is not the best corner to have a hole.
It's a bit full of inductors.
It's kind of,
That's it.
Yeah.
So yeah, it does a really effective job. So it's made up of aluminium base plate heatsink. The blower fan screws directly to that, so it's got some pretty robust threaded inserts. It screws together really strongly. 2 push pins either side, and on the underside we have strategically positioned thermal gap pads. So these contact the components that get hot, so PMU, SOC components on the board, and they're at different heights, so it helps stabilize the heatsink when it's mounted on and has good thermal conductivity. And the fan is similar to the Pi case, so it's a 4-wire fan. It's power, ground, and PWM. So it's temperature control fan as well, so it will tailor its speed depending on how hot the CPU gets. So it will go through the different gears, and it's a really silent fan. I think that was really important when we specified it. The noise only really kicks in at the top speeds, so that was really important for us to look at. It's also got a tachometer wire as well, so you can look at the RPM of the fan through the software as well, which is really useful. But yeah, it will be assembled fully out of the box. It will come like this. The user will just take away the backing paper from the thermal gap pads, then it just mounts pretty easily by pushing onto the board and connect the wire, and ready to go.
That's cool. And how's the aluminium component made?
Sure. So there's a kind of shape we wanted to produce. We knew it wanted to have heatsink fins. The first operation in manufacture is an aluminium extrusion. So essentially the side profile is put through a die. It comes out as a big long bar with all the heatsink fins and the side profile all the way through. Then it's CNC machined, and it's got a stamping process as well to create the profile. So the edge is a secondary operation, and then we have the threaded inserts pressed in. So there's a few different operations, but
So it's CNC to make it's extrusion to make the slots that way, the heatsink slots that way, CNC to make them that way, and then stamping to generate the outline.
Exactly, yeah. So the main fin profiles are through the extrusion, then it's cross-cut with CNC. The profile is stamped as well, and then the CNC kind of cleans up the edge, essentially.
Right. And your blower is blowing into this forest of fins. It's pulling air in like that and then blowing it tangentially outwards into the forest.
Exactly, yeah. And we, with the manufacturer's help, we put a waveform into the fins as well, so it's got that little bit of extra surface area just to help with
I noticed the fins, they're not just rectangles, they're little Christmas tree shapes. Yeah.
So just that slight bit of detail just adds a little bit more performance.
A couple of degrees?
Yeah, I'm not quite sure. It's hard to do in without, but yeah, it was recommended to do, so it must make a substantial difference. Yeah. But yeah, it's hopefully quite a kind of simple product, and will come fully assembled and can just plug on. So.
Yeah, and I mean, I think there's that thing about it being, because one of the things I've always had the problem with the case is that on my, at home it's fine. So it's sat on because I don't really do much, it's just sat there. It's using, I've got one of the computers I've got sat there. It's just the Raspberry Pi, it just sits there. But at work, because I'm always plugging things and unplugging things, I put it into the case, and then about, a few days later, I have to remove the case to unplug something and plug something else in. And then, so this does allow you to just leave it plugged, leave it like that, leave that as a cooling solution rather than inside the case. And I think there is definitely both of those options are valid kind of uses of the Raspberry Pi. So just sat on the desk as a raw board is really good as well.
That's great. Yeah, I think keeping it small and compact was just an absolute requirement, because as you say, it just gives you still the freedom to do what you'd like with the Raspberry Pi with the insurance of this cooling solution on board.
Yeah. So how good is in comparison the cooling?
Yeah. So this is higher performance because it's obviously in open air and it's dedicated. It's got metal componentry as a heatsink, so this is better performance. There's probably about a 10-degree difference between the two. Obviously a lot of variables in thermal testing, but on a like-for-like test, this is probably 10 degrees cooling better.
Yeah. And these fans are rated for quite a lot of use. Right, they're not intended to fail after a year.
That's right. Yeah, it's years and years. So yeah, I think 50,000 hours. So a good.
And that's 50,000 hours of use. So it's 50,000 hours. You know, if your Raspberry Pi is idle, the fan's not running. So this really is 50,000 hours. This is intended to be 50,000 hours of pretty intensive use of your Raspberry Pi.
That's right. And obviously the lower temperature trip points, it won't be going full speed, so that will extend the life. And we did pick particular fan technology, so like the bearing type is built for longevity and low noise. So there's the spec of the fan was very important in extending its life and being really quiet.
Yeah, it's kind of something we learned from the other one. It was a bit whiny. We do, yeah. So it's good to have a much quieter solution.
It's quite challenging. It's not just the fan spec, because often you can have a fan running in mid-air and it's super silent, but when it's in contact with something, especially plastics, it's reverberation, and quite a lot of work was done how we mount the fan on the case just to reduce vibration and still, have a low noise solution.
It's fun, and both of these are available at launch. In significant quantities of these will be available when the product launches. Yeah. It's cool. So everyone gets maybe not quite everybody gets a case, but everybody gets a thermal solution. Yeah. Nice and early on, in parallel with having a design that, as we say, has been designed to be cooler at a given workload than its predecessor. Yeah. Exciting. That's awesome. You keep doing more industrial design.